So next up we have isosceles polygons. First we're going to talk about a triangle. So an isosceles triangles have at least two sides of equal length. Resulting in congruent base angles. So here if we take a look at our triangle, we see these two little marks here mean that these two sides are congruent. They have equal length, so that satisfies our definition for isosceles. And these base angles here are congruent. For an isosceles trapezoid, I'm going to write the definition over here on the right. Isosceles trapezoids have have non-parallel sides. Have non-parallel sides that are equal in length. Also resulting in congruent base angles. So if we take a look at our diagram here, for a trapezoid, we see these two sides are not parallel. These tick marks tell us that they are congruent. That results in these congruent base angles. The base angles are the angles when it's sitting down like this. So these are the two angles that would be like touching the ground if you sat this down like on the ground. So these are the base angles. You can also think of them as the angles that are opposite your congruent sides. So here if I draw a line opposite these sides, right? Those are two ways to think of it. So either the angles at the bottom, at the base angles, you can also think of them as opposite these sides, these congruent sides. Okay, so that's our definition for isosceles polygons, at least for these two types. And then take a minute and try example number, for this video, number 1. So, in triangle ABC below, AB is congruent to BC. So I'm going to put my marks here. AB is congruent to BC. And the measure of angle B is 55 degrees. So my angle B is 55 degrees. What is the measure of angle C? Well, we know again that all of the measures, if we add all of our angles up together, they're going to sum to 180. We also know that these two base angles are going to be congruent because this is an isosceles triangle. Our definition over here tells us if we have two congruent sides, it's an isosceles triangle, and that results in congruent base angles. So if I call my angle BAC here, if I call this X, I can also call my angle BCA X, because they're the same angle. So 55 degrees plus 2x, right, because there's two x's here. If I add all these up together, it's going to sum to 180. So if I subtract my 55 from both sides, I end up with 2x, so we should put a degree mark on this too, 2x degrees equals 180 minus 55. That's going to give me 125 degrees. Okay. And then my 2x degrees equals 125 degrees. I divide by 2 on both sides. Remember, I'm looking for my x, my measure of my angle C here. I call that x. So x is going to equal 125 divided by 2. And that is going to get me 62.5 degrees. So here my measure of angle C is going to be 62.5 degrees. Then finally, we're going to have our sum of interior angles of a polygon. So here I have a polygon, it's a 5-sided polygon, 1, 2, 3, 4, 5, so that's a pentagon. And I want to know what is the sum of all of my interior angles. Interior means on the inside, so all of these angles in red that are on the inside of my shape. That sum can be found by this formula, n minus 2 times 180, where n is the number of sides in the polygon. So for this shape here, it's a 5-sided shape. My n is going to be equal to 5. 1, 2, 3, 4, 5. If I plug that into my formula, so 5 minus 2 times 180, I just plug that right into my calculator, and I'm going to get out 540 degrees. So all of the interior angles in this pentagon are going to sum to 540 degrees. So take a minute to try this example on your own. The figure below is a regular hexagon. What is the measure of one of the interior angles of the hexagon? So the fact that it's regular, this word regular, means that all of these interior angles are congruent. So these are all the same angle measure. So first let's find what the sum of all of these are going to be. And we said on this side over here, we can get that by doing n minus 2 times 180, where n is the number of sides in the polygon. So here my n is 1, 2, 3, 4, 5, 6. I have 6 sides. So my n is going to be 6. So if I plug 6 in for my n, so I get 6 minus 2 times 180. I plug that into my calculator. I get 720 degrees for the sum of all of these angles. But that's not what we're looking for in the problem. It wants to know what's the measure of one of my interior angles. So since I know that these all are the exact same angle measure, if I have the sum of all of them, so all 6 of them summed together, if I divide by 6, I'll get the measure for one of them. So I'm going to take my 720, divide it by 6, and I will get 120 degrees. So 120 degrees is the measure of just one of these angles.